Hello students, in today's class we are going to see about the various electrochemical technologies that have been used for environmental remediation. First of all, let us see what is environmental remediation. The term environmental remediation tells about the removal of pollutants or contaminants from environmental media which are listed as soil, groundwater, surface water, and air. Many physical, biological, photolytic, chemical, and electrochemical techniques are in use for the removal of pollutants. Various chemical or any other substance which has been added to the environment and which is going to affect it in due course is called a pollutant. Whatever pollutant which has been present in the environment is going to destroy the environment and it will not lead to the sustainability of the environment. So it is very important to study about the various techniques that have been adapted for the removal of these pollutants which are going to harm the environment in due course. The problems associated with hazardous wastes can be avoided if proper actions are taken in the early stages. We have three conditions for the early removal of these pollutants from the environment. First of all, we can do waste reduction, that is cutting down the amount of waste at the origin itself. In the initial stages, how we are going to reduce the waste what have been dumped into the surrounding environment as a sediment or as a solid substance which is going to be there in the environment for a long period of time. The second method, it can be waste elimination. Instead of throwing any chemical which is in the hazardous form, it can be replaced by suitable technologies, suitable methods, or suitable materials with some other good chemical which is otherwise called as a green chemical that will not harm the environment in any sort. The third one is using various treatment processes which reduce the amount of waste requiring ultimate disposal. So we are not going to do the disposal process. Though it has been, the pollutant has been added to the surrounding environment, by using treatment process, it can be removed without doing any much harm to the environment. And the amount of uh, disposal what is required is not that much immediate. So this is the idea what we are going to adapt as the third one for the environmental remediation. Contamination of the environment with a lot of chemical pollutants is inevitable. Advances in technology and increased consumer demand for goods and services have resulted in increased amount of pollutants which have been added to the environment. These pollutants are usually categorized into different types. The way by which they are actually affecting the environment, and the regulatory bodies have listed these as most dangerous substances and they have been called as a blacklist substances. This blacklist includes persistent organic pollutants such as organohalogen, organophosphorus, and some heavy metals and some other organometallic complexes. Here we are seeing two pictures. The first one shows how an effluent from any industry is being added to the water what is nearby. And the second picture depicts the groundwater, the soil, what is in the nearby environment is being affected by the effluent what has been added to the soil or the groundwater, and which in turn affects the plant or the agricultural products which are grown in that nearby soil using the groundwater what has been affected by the pollutant. So here we can see how the soil is getting polluted by the effluent what has been added to it. And after treatment, so what we are going to do for this type of destruction, what has been done to the soil or to the groundwater? Here the groundwater results in the deterioration of the production of the healthy products, so it has to be treated. So when we do treatment processes, various environmental technologies, what has been added for the effluent treatment, if we are going to adapt it before letting the groundwater being affected by the effluent what has been added in due course, it will result in the proper growth of the nearby soil, which is used for repeated processes. There are many techniques which are used in the remediation of wastes, which are categorized as physical, biological, photolytic, chemical methods. Of these, electrochemical methods are providing elegant solutions for remediation of environmental pollutants. They offer several advantages over other methods such as versatility, energy efficiency, amenability to automation, environmental compatibility, and cost effectiveness. These electrochemical techniques are considered as a physiochemical discipline with wide ranging applications that are directly or indirectly useful in our life. These include chemical conversion of energy generation, energy storage, surface technology, biological systems, corrosion, electroanalysis, electrosynthesis, pollution control, recycling of wastes, wastewater treatment, environmental remediation, and finally disinfection. Notably, elegant solutions for remediation of environmental pollutants have been provided by electrochemical methods. These electrochemical concepts provide various methods for remediation of a variety of dilute pollutants or organic contaminants that are coming from agricultural land which have been added to the agricultural soil in the form of fertilizers and organic complexes with metals and recovery of heavy metals. These concepts have several advantages over other methods because of their environmental, cost effective compatibility methods. Let us know what are the advantages of using electrochemical techniques for environmental remediation. These techniques have been used since the early 1960s for the treatment of wastewater containing various pollutants which are nothing but metallic in nature or organic and inorganic compounds. In an electrochemical cell, we have redox reactions and phase transfer reactions, dilution, concentration changes happening, and biological and photocatalytic reactions which can be monitored directly or indirectly. Separation of the reactant products by implementing various established designs or controlling reactors or reaction conditions. Pollutants of different phases, solids, liquids, or gases could be done with this type of electrochemical techniques. Electrochemical processes are generally simple and if properly designed, they are cost effective too. External control of the electron transfer across the interfaces, because in any electrochemical reaction we have the transfer of electrons. So these electron transfer, they are going to occur between any two phases and they are causing the electrons to obtain a specific energy, thus making the electrons as the main reagent for the interface reactions. And this shows that an electron can act as a clean reagent which promotes environmentally useful, good adaptable technology. The applications of electrochemical technologies for industrial recycling and effluent treatment include the removal of pollutants, recovery of the polluted water or soil, and separation of dissolved metals and the destruction, complete eradication of the dissolved organic materials and various treatment of waste gases which are not important for the environmental processes. Electrochemical instruments used for the analysis of aqueous media includes four popular methods. These are conductometry, voltammetry, potentiometry, and amperometry. If the qualitative composition of the ionic contaminants which are present in any sample is already known, and if the concentration of the pollutants are not going to change, the first method, conductometry, helps us to determine the quantitative amount of the contaminants present. The second method is the most reliable electrochemical method, which enables the qualitative and quantitative determination of non-ferrous metal ions. The third one is potentiometric method, which has ecological applications, and here the pH of the solution which contains the pollutants is calculated. The fourth method is amperometry, which helps to calculate the concentration of dissolved oxygen. While considering the purification procedures for removing the pollutants by electrochemical methods, two types of adsorption methods have been incorporated. The first one is electrocoagulation or adsorptive purification, and the second one is electrosorptive purification. In this, the adsorptive purification method is able to liberate the water from contaminants which cause its bad smell and taste. It is highly effective for the removal of xenobita and some traces of petroleum products. In some cases, it can even decolorize the water. The resulting sludge, which is settling at the bottom, can be used for manufacture of building materials and road cover materials. Various electrochemical technologies exist for effluent purification. These methods are used in many plating and metal finishing industries for rinsing water containing non-ferrous metal ions and while depositing for corresponding metals at the anode. The first method which has been employed for purification of effluents is by adsorption procedure, which is named as electrocoagulation. Here, the adsorbent is obtained electrochemically. The effluent containing both organic and inorganic contaminants, heavy metal salts, are subjected to electrolysis with steel or aluminum anodes. During electrolysis, these anodes dissolve at the electrochemical cell, while hydrogen is evolved at the cathode. The layer next to the cathode, water subsequently contains water in the gap between the electrodes, becomes so alkaline that the dissolved iron or aluminum ions will form highly porous hydroxides. The second type of purification by adsorption is electrosorptive purification. Let us see what is meant by electrosorption. It is defined as the potential induced adsorption of ions onto the surface of the charged electrodes. When a lower voltage, say about 1 to 1.5 volts, is applied to the solution at which no electrolysis reactions occur. So at that time, there is no electrolysis, but the interface between the electrode plate and the solution forms an electric double layer structure with a certain adsorption capacity. A material with a high electronic conductivity, usually activated carbon or carbon materials, are used as adsorbents. The adsorption of most substances depend on the charge of the adsorbent surface. The electrostatic adsorption of ions at a given sign increases based on the charge of the adsorbent surface. If it is oppositely charged, the adsorption of ions of a particular sign will take place on the adsorbent surface. whereas the absorption of most organic substances is likely to occur on uncharged adsorbent surfaces. In this electrosorptive purification, the adsorbent is polarized from an external source in such a way that its potential will be most favorable for the absorption of particular selected contaminants. The adsorbent is readily regenerated afterwards by changing the potential to different values where the contaminants become desorbed from the surface of the adsorbent. Purification of water by electroflotation is of interest too. In ordinary flotation, a gas, which may be air, is passed through the water to be purified. Its bubbles, while rinsing, carry along the surface active contaminants as well as colloidal or other suspended substances in the water. The finer the gas bubbles, the more efficient the flotation, and the contaminants float on the surface at an early stage. In electroflotation, the gases hydrogen and oxygen are adsorbed by electrolysis with the aid of electrodes arranged at the bottom of the electrolysis process, which is happening in the electroflotation vessel. The size of the glass bubbles produced depends on solution pH and electrode charge. An efficient method for degreasing and purifying various effluents obtained from different sources containing organic contaminants such as phenols, dyes, pesticides, surfactants, and pharmaceuticals can be electrochemically oxidized to carbon dioxide and water, and in the case of nitrogen containing substances, where they can be converted into nitrogen. This anodic oxidation of many organic substances is easy. For the complete oxidation of organic substance to carbon dioxide in water, a rather large amount of energy is consumed. The anodic oxidation of organic substances is a multi-step process. Here, the anodic processes are conducted at high potentials. Radical type intermediates often are formed that lead to the polymerization of the organic substances and to passivation of the anodes. An alternative to the direct oxidation of organic substances are the methods of indirect oxidation with the aid of oxidizers present in the electrolytic cell in situ. These oxidizers can be obtained both anodic and cathodic processes. Anodic agents are the salts of hypochloric acid, hypochlorites, and the permanganates, the persulfates, and even ozone. Among electrochemical methods of water purification, we can also list various electromembrane technologies in which electrodialysis is very important. Electrodialysis is quite unique among practical desalination processes because it literally desalts the feed source, whereas in other processes, actually water is removed after purification. Electrodialysis is a membrane process utilizing charge selective membranes and is pressure based like reverse osmosis. It is possible to manufacture membranes that are charge selective and that allow only ions of appropriate charges to pass through the membrane. The simplest electrodialyzer consists of three compartments that are separated by semipermeable membranes, which are usually cation and anion exchange membranes. In this diagram, we can see the electrodialysis process setup. The water to be purified is supplied to the central desalination compartment. In the outer concentration compartments, we see the electrode setup between which a certain potential difference is applied therein. Under the effect of the electric field, ions pass through the membranes so that the concentration of ionic contaminants in the central compartment decreases.